Before we do this this question here, I just want to add one thing onto our recap. One more quick thing. If you've got, you see there's 4 pieces of information. We've got that one, this one here being half of that one, and this one being parallel to that one. 4 things, right? Okay. If they give you any 2, you automatically know the other 2. That's how midpoint theorem works. All right. So if I give you this, there's a line. I'll tell you those are equal, and I'll tell you that this is 10 and that's 20. Well, then what do you know? You automatically know that they're parallel. That's because of converse midpoints, and those two are equal. Converse midpoints. What other options can we do? Let's say we've got this. Let's say we've got this being parallel. There's one, and I'll tell you this is 15 and that's 30. All right. Well, that's 2 pieces of information. That give me 2. So what do we automatically know? We automatically know that those are cut in half and those are cut in half. Converse midpoints. What other one can I do? Which one haven't I done? Let's do these parallel and that cut in half. Well, if that's true, then what do we know? That this was also cut in half, and whatever this is doubled. Okay, are you good? Okay, so now let's just look at this one example together. The first thing is read all of this and check that that information is on the picture. Okay. Yes, that's that, or wang, that's there, yes. UVR is a straight line, thank you. UV equals 10. Okay, so they're telling us that this here is 10. Now they want the length of UR. That line there. All right, what do we notice? I just want to show you guys something very quickly. I'm going to highlight this triangle here. You see this triangle? What information have they given us in there? Just the fact that those 2 are cut in half. Nothing else. We don't have the parallel lines, the other side equal, we don't have anything else. So it looks like a midpoint theorem triangle, but we don't have enough information yet to actually use the midpoint theorem. But now look at this triangle here. Let's draw it in yellow. You see this triangle here? Midpoint theorem is in there, you see it? Those are equal. It was like that. Look at this yellow triangle. Do you see? I'll even put this one over there like that. Do you see that those 2 are equal there? This one here is equal to this one here is equal to this one here, and those 2 there are equal. So what do we know? We automatically know that this is parallel to this. Cool, I'm going to write that. TS is parallel to UR because of midpoint theorem. Okay, now because of that, I'm going to go back into this black triangle, the original one. And now, not only do I have these 2 equal, like I always had, but I've also got the parallel lines, right? Yeah. So now I have midpoint theorem inside that triangle. In fact, converse midpoint theorem, if you saw my previous video. So now it's very clear to see that if this here is 10, TS is 20. So TS equals 20, and the reason for that is converse midpoint theorem. Okay, cool. And now, grade 10s, we're going to go back into the yellow triangle because I now have this thing here being 20, right? So now back in the yellow triangle, I've now got this entire length here that they were looking for in the very beginning to be 40. So UR is 40. UR equals 40. And that's also midpoint theorem. Okay, there we go. Cool. A complete. B, the length of VR. VR is just, I'll do it in blue, it's just this line here. But that's too easy because UR, the whole of UR was 40, right? And this UV bit here is just 10. That makes the VR part 30. And there's no geometric reason for that, it's just logical. All right, complete.